Assalamu alaikum and welcome back to our channel, Pakistan Zindabad, the next world superpower. This is episode 30, and today we are cracking open a strategic document of, well, a truly historic scope.
It's a blueprint, really. Something that outlines the creation of the first ever unified tricontinental air and missile defense network for Muslim nations.
We are diving deep into the strategic vision presented in the highly discussed book, The Nuclear Umbrella, written by Mr. Zaheer Ahmad Meer. Specifically, we're analyzing the excerpts on what he calls the Unified Muslim Air and Missile Defense Shield.
Which the source material often refers to as the shield of the Ummah.
And this plan offers a remarkable window into a major potential shift in global security architecture.
What's fascinating here, and I think what really grabs you, is the sheer scale and ambition of it all. We're not just talking about theoretical defense concepts or some far-off future aspiration.
No, this is the how-to.
Exactly. We are analyzing the proposed architecture, the technical, the organizational structure for a massive system that's designed to secure the Ummah independently.
And that word independently feels really key here.
It is. This is a deliberate step away from reliance on any external military powers. This proposed project aims to secure the collective sovereignty and, the safety of nearly 2 billion people spread across 3 continents.
And the need for this is, well, brutally clear when you look at recent history. The source material emphasizes a chilling truth that has really defined modern conflict, that modern warfare is decided in the sky long before soldiers ever meet on the ground.
And when we talk about vulnerability, you're looking at a map that stretches from Gaza to Yemen, from Syria to Iraq, Pakistan to Saudi Arabia, all these places facing continuous, diverse, and increasingly sophisticated aerial threats.
Threats that their existing isolated national defenses have proven unable to fully counter.
Indeed. That history of vulnerability across the Muslim world, where airspace violations, precision missile strikes, and sophisticated drone attacks have become almost routine features of conflict, that is precisely the core motivation for this blueprint.
So the mission here, as the source defines it, is pretty unambiguous.
And unprecedented. The mission is to create an integrated air defense network that isn't just multinational, it's tricontinental. It's designed to cover vast geographical zones and possess capabilities that are, frankly, meant to rival major systems like NATO's integrated air defense structure.
That comparison to NATO really underscores how massive this undertaking is. So for you, our listener, what is our mission today?
We are analyzing the specific technical and organizational blueprint for this 3-layer shield.
Think of this deep dive as a shortcut, a way to understand the complex architecture of modern integrated air defense, and to see how all these disparate national assets from different countries with different suppliers are intended to be fused into a single, cohesive, civilization-wide shield.
We'll break down the layers, we'll examine the really daunting task of establishing a unified command and control structure, the MADC, and critically, we'll run through some detailed crisis scenarios to see this integrated defense strategy in action.
Because it's not just about having the hardware.
Not at all. It's not about compiling a list of existing missiles. It's about achieving seamless, instant coordination, data fusion, and unified fire control across vast geographical distances and, very complex political boundaries.
And it all starts with understanding what they are defending against. So let's start right there, in the air, with the foundational premise outlined in the source: the unbearable threat environment and the need for unity.
The first thing the source material does is it catalogs the sheer complexity of modern aerial threats. And it really drives home the point that defense is no longer about detecting a single approaching fighter jet.
No, it's a multi-dimensional chess game now.
Exactly. The sophistication of modern warfare means your defense has to be multi-spectrum. It has to be capable of simultaneously addressing high-altitude, high-speed threats alongside, low-altitude, low-cost saturation threats.
Okay, so let's break down that comprehensive catalog of modern aerial threats, the blueprint outlines. It seems to span across 5 major categories.
Right, and each one presents a unique and often overwhelming challenge to a traditional, isolated defense system.
Let's start with the big ones, the existential threats.
Yeah.
Ballistic missiles. What are the specific challenges the blueprint focuses on there?
The blueprint highlights threats with a range up to 3,000 kilometers. The challenge with ballistic missiles is really threefold. You've got altitude, velocity, and trajectory.
They go up into space, basically.
They do. They rise above the atmosphere. They often use mid-course maneuvering, which makes early detection by ground-based systems, which, rely on line of sight, extremely complex.
So by the time a single country sees it, it's already on top of them.
Pretty much. The re-entry phase is hypersonic, leaving mere minutes, sometimes even seconds, for reaction and interception. If you only have a single national radar footprint, you just cannot track the full trajectory of a long-range ballistic threat from its launch all the way to its terminal phase.
So the target nation is basically getting the tracking data in the final seconds.
Which is a recipe for catastrophic failure.
Okay, so that's the classic high and fast problem. But then you have the opposite. The threats designed to be sneaky, to actively evade detection. Stealth aircraft.
And stealth aircraft fundamentally challenge the entire concept of a perimeter defense. They're designed specifically to operate within the blind spots, the gaps created by non-integrated individual national radar systems.
So a good radar system in one country isn't enough.
Not even close. A high-quality national system might detect a large traditional aircraft, sure, but tracking the subtle, low-observable signatures of stealth assets requires not just powerful radar, but what the source calls network-centric data fusion.
And what does that mean in practical terms?
It means radar data from hundreds of different sources, all operating at different frequencies in different locations, has to be instantly combined and analyzed by supercomputers. The source is adamant on this point. Individual national radar systems cannot guarantee consistent detection against a modern stealth threat.
Right. So leaving to the other end of the cost spectrum, we have the threats that have dominated recent conflicts. UAV swarms and loitering munitions. This is where just the sheer numbers become overwhelming.
This is arguably the most critical shift in modern air defense. Swarms are cheap, they're expendable, and they're designed specifically to overwhelm and saturate high-end defenses.
I mean, you can't shoot a $3 million missile at a $50,000 drone.
You can't do it 50 times, that's for sure. Imagine a single battery of a multi-million-dollar interceptor. It might handle 2 or 3 expensive incoming threats. But a coordinated swarm of 50 or 100 low-cost drones presents a radically different problem: economic feasibility.
And what about these loitering munitions, the so-called suicide drones?
They present a different challenge. They patrol an area, waiting for a target. This demands constant, persistent surveillance that just wears out human operators and sensor systems. It's a battle of attrition.
And then there's the difficulty of tracking assets that intentionally fly low, trying to hide from conventional radar grids. I'm talking about cruise missiles.
Cruise missiles are the terrain huggers. They exploit the Earth's curvature, the radar horizon, and natural features like valleys and mountains to stay below the conventional radar's line of sight.
So unless you have eyes in the sky.
Exactly. Unless you have continuous integrated airborne radar coverage, like an AOSCS plane, or a deeply meshed network of ground-based radars sharing data in real time, tracking and engaging a cruise missile is a tremendous hurdle. They're often detected too late to launch an effective interceptor, especially if they maneuver.
And finally, the blueprint stresses that the most insidious threats are often the ones you can't see. Non-kinetic threats like electronic warfare and cyber attacks.
This is the critical and often overlooked dimension of defense. Modern air defense is entirely reliant on perfectly functioning sensors, communication links, and data processing.
So you attack the brain, not the fist.
Precisely. Electronic warfare, or EW, can jam essential air defense radars, essentially blinding the system at the moment of crisis. Or worse, it can spoof them by injecting false information, making them see things that aren't there.
And cyber attacks could be even more devastating.
Absolutely. Cyber targeting of these control systems, the brains of the operation, can render interceptors useless, provide false targeting data, or even prevent the command to launch. So a unified defense system has to include shared, robust, and constantly updated cyber and EW countermeasures to protect the network itself.
That catalog of threats alone is pretty terrifying. But what really drives the point home in the book are the case studies in vulnerability real-world attacks that prove why unified defense isn't just a luxury, it's an existential necessity.
These are the watershed moments. They provide the empirical justification for the entire Shield of the Ummah concept. Take the sophisticated drone and missile attack on Saudi Arabia's Aramco infrastructure in 2019.
I remember that was a huge shock.
It was. That incident demonstrated that even a nation with billions invested in top-tier Western defense systems was vulnerable to a complex, multi-axis, low-signature saturation attack. It exploited radar gaps and successfully saturated their isolated perimeter defenses.
So it wasn't a hardware failure, it was a system failure.
Yeah.
A failure of coordination.
Precisely. Or you could look at the repeated Houthi ballistic missile strikes targeting the UAE, often aimed at civilian targets like airports. Those strikes showed that cross-border threats, originating hundreds of miles away, could bypass existing national defenses with regularity.
It proved that just defending your own border isn't enough anymore.
It's strategically insufficient against modern long-range rocketry and, sophisticated non-state actors.
And we can't forget the extremely high-stakes incident involving Pakistan.
Yeah.
The BrahMos intrusion episode. That moment really highlighted the risks of non-integration.
That event was a wake-up call. You had a sophisticated nuclear-capable cruise missile, allegedly launched by accident, entering sovereign Pakistani airspace. It underscored two immense risks. First, the technical need for immediate, reliable detection and interception, regardless of the source or intent.
And the second risk?
The risk of catastrophic escalation. The stakes of that single incident were enormous. It could have potentially triggered a massive military mobilization or even a nuclear escalation based purely on a failure to detect, track, and neutralize the threat immediately.
Then you have the ongoing situations, the persistent airspace violations in places like Syria and Iraq, and the continuous guided missile bombardments in Gaza.
Right, and those examples, spanning years, highlight continuous aggressive violations of sovereignty through precision strikes and sustained air dominance by external powers. They illustrate the strategic result when an adversary has overwhelming aerial superiority and the targeted nations lack the ability to effectively challenge that control or coordinate a protective response.
It's what the source calls the constant bleeding that happens when you lack air parity.
Exactly.
So the crucial insight that the source draws from all these examples seems to be this hard, undeniable conclusion that cuts across any political differences.
It is the unifying statement of the entire project. No single Muslim nation can guarantee its safety alone against the threats we've cataloged. The complexity, the range, the sheer saturation capacity of modern aerial warfare means that only a united, shield-fused, integrated network can secure collective sovereignty and ensure the necessary depth of defense.
So if unity is the acknowledged solution, why hasn't it happened already? The book wraps up this section by analyzing the failure of disjointed defense systems. It's not that these nations lack assets, right?
Mm-hmm.
Many have extremely impressive hardware.
That's a critical point, and the blueprint doesn't ignore it. The source is very clear. There's a huge catalog of existing assets that are individually high-tier and incredibly expensive.
Like what?
Well, you have Pakistan with its sophisticated long-range early warning radars. Saudi Arabia operates some of the most advanced U.S. systems available, like high-end Patriot and Tate-on missile battery.
And Turkey.
Turkey contributes major assets, like the Russian-supplied S-400 system and its world-leading advanced drone fleet. The UAE has the A-Day. Egypt maintains powerful multi-layer systems, including Russian Buk and S-300 batteries.
That is an immense inventory of cutting-edge technology. And yet the collective impact is somehow less than the sum of its parts. That points directly to this massive integration gap.
And the failures here boil down to really three things: political trust, technical standards, and a common doctrine.
Let's start with the technical side.
First and foremost, there's a critical lack of interoperability and common communication protocols. If a Turkish S-400 system can't instantly and natively share targeting data with a Saudi Patriot system, the defense response is fragmented, it's slow, and it's reactive instead of proactive.
They just don't speak the same digital language, as the source puts it.
Exactly. Because their operating systems and data links were never designed to cooperate, which means they fail to share critical real-time radar data, especially across national borders.
And that's where the blind spots come from.
Precisely. Imagine Pakistan detects a cruise missile launched 2,000 kilometers away. That raw data needs to be instantly integrated into the fire control system of every relevant defense battery across the Gulf and North Africa in milliseconds. Isolated systems just can't do this. They pass information through slow, bureaucratic channels, which is useless in a missile attack.
And that inability to detect long-range threats collectively forces nations into a reactive posture.
It forces a situation where a threat might only be detected when it's entering your immediate airspace. That cuts vital minutes from the response window. A unified system, pooling all detection assets from different geographical points, space, air, sea, ground, achieves a far greater early warning horizon.
And that time is everything.
It buys the crucial time needed for the central command to make complex deployment decisions.
And finally, we hit the big one. The organizational failure. The lack of coordinated response planning and unified command authority. This has to be a massive political hurdle.
It's the ultimate failure point. Without a central, trusted authority, there's no defined protocol for threat prioritization or interceptor allocation.
Right. If two countries could intercept the same missile, who fires?
Exactly. Without coordination, you risk either duplication of fire wasting millions of dollars on a single target, or worse, both nations hesitate because they think the other will fire and the threat gets through. The blueprint argues that this organizational paralysis, more than hardware quality, is the primary reason for past defense failures.
So the transition is clear. The mission here is to permanently fix this political and technical paralysis by building a robust, layered shield. And that brings us perfectly to Section 2, the core blueprint, the three-layer integrated shield.
This is where the technical architecture, the real engineering marvel of the plan, comes into sharp focus.
And this three-layer system is the solution to that threat environment we just laid out.
It is. It mimics the deep defense doctrine you see in the world's most advanced military alliances. It's designed to ensure redundancy and depth. If Layer 1 detects the launch, Layer 2 attempts the mid-course kill, and Layer 3 performs the terminal kill. It's defense in depth across thousands of miles.
Okay, let's start with the outer shell, Layer 1. The Early Warning and Space Surveillance Network, or EWSN. What's its primary function? Why is it so critical?
Its function is revolutionary for this region. It's the undisputed eyes and ears of the entire system. EWSN is designed to detect high-speed, long-range threats, specifically ballistic and cruise missiles, at the earliest possible moment.
We're talking minutes to hours before they would even be visible to local radar.
Exactly. Strategically, its role is to eliminate tactical surprise, which is always the enemy's greatest weapon.
So how is this built? The blueprint describes it as an integration of highly specialized assets from various states, creating a truly seamless grid.
And this is the genius of the architecture. It takes existing specialized assets and fuses their data. The blueprint details a complex integration. Pakistan contributes its extensive network of long-range, ground-based radars, which are designed to scan vast swaths of territory.
Then Turkey comes in with a different kind of asset.
Yes, Turkey contributes crucial space surveillance assets, which are vital for tracking threats that exit and re-enter the atmosphere, like ballistic missiles.
So the space assets give the initial launch alert.
That's the idea. Then Saudi Arabia provides its high-powered ballistic tracking radars, which are essential for mid-course tracking and handing off targets to the interceptor batteries. Egypt's contribution is its Mediterranean radar grid, which closes off a vital western and northern approach.
And it's not just the Middle East and North Africa.
Right. Malaysia adds its maritime radars, extending the EWSN into key oceanic approaches, which is essential for detecting sea-launched cruise missiles.
So combining those specific assets, it dramatically expands the overall capabilities. What specifically can this fused Layer 1 achieve that separate national systems simply cannot?
Well, now you're looking at strategic capabilities, not just local detection. First, guaranteed detection of ballistic missiles immediately at launch. By pooling space assets and long-range ground radars, the system gives the central command the maximum possible warning time, often 15 to 20 minutes before impact.
Which is an eternity in missile defense.
It is. Second, consistent tracking of low-altitude cruise missiles becomes possible over massive distances because the composite radar coverage eliminates the gaps caused by terrain and the radar horizon. It gets rid of those blind spots we talked about.
And it helps in the swarm problem.
Yes. Third, identifying and tracking large drone swarms becomes manageable. Instead of overwhelming a single nation's processing system, the composite network pools its processing power to track hundreds of small, slow targets at the same time.
And the fourth capability seems to be about future-proofing the system against hypersonic threats.
It is. Hypersonic weapons, traveling at over Mach 5 and maneuvering dynamically, demand vast, persistent sensor coverage. Layer 1, by fusing specialized space and high-altitude tracking radars, offers the sustained observation capability you need to predict and respond to these extremely fast threats.
So the end result of Layer 1 is what? A single, unified alert.
The ultimate output is a unified instant alert issued to the command structure and to all 57 Muslim countries simultaneously. This ensures every regional player is operating with the same common operational picture in real time.
Okay, so moving inward. If Layer 1 is a strategic eye, then Layer 2, Theater, Air, and Missile Defense, or TAMD, is the heavy interception force.
This is the mid-range layer, the muscle of the defense. It's focused on missile interception and high-altitude air defense once a threat is confirmed and tracked by Layer 1.
And the strategic challenge here is less about detection and more about making everything work together.
Far more. It's about achieving genuine system integration, making diverse missile systems, born of different proprietary military cultures, cooperate efficiently and effectively.
I want to pause on that for a second. You mentioned U.S. Patriot, Russian S-400, and Chinese HQ-9 systems, all being part of this Layer 2. That diversity sounds like an engineering and political nightmare.
It is perhaps the hardest technical hurdle. The blueprint calls for a common fire control network, which is essentially a central nervous system for all the interceptors. You're trying to harmonize systems that use completely different data formats, different radio frequencies, different fire control software.
I mean, the list of systems is staggering.
It is. You have Pakistan's HQ-9P, Turkey's S-400 batteries, Saudi Patriot and Theade systems, Egyptian Buck and S-300 systems, UAE Falcon systems.
And the source even mentions the optional future integration of Iranian Bavar systems. That level of diversity is unheard of in any existing military alliance. So how do you possibly unify that?
The answer lies in the unified doctrine requirements that would be enforced by the Central Command, the MADC. The doctrine has to solve the fundamental coordination failures we discussed. First, eliminating duplication of fire is paramount.
So no two missiles for one target.
Right. The MADC must instantly calculate the optimal interceptor based on range, cost, probability of kill, and ensure that two expensive multi-million-dollar missiles don't target the same $500,000 cruise missile. This would require some very advanced AI-driven algorithms.
So the algorithm weighs the cost-benefit analysis in milliseconds, choosing between, say, a Russian S-300 or a U.S. Patriot.
Precisely, and without human intervention slowing it down. Second, the doctrine has to focus on removing the gaps between national defense sectors. The system must define overlapping engagement zones, ensuring a seamless transition of tracking and targeting when a threat crosses a border.
Which means the system must allow for shared, rapid targeting data across those borders, bypassing national firewalls.
Yes. For example, a Turkish S-400 operator must be able to use tracking data generated by a Pakistani radar or a Saudi AWACS to launch an interceptor over Syrian or Iraqi airspace if the unified command protocol requires it.
That level of cross-border data transfer, guided by a mutually agreed launch authority, is what makes it a real shield, not just a collection of agreements.
That's the leap.
Okay, finally, we reach Layer 3. Point Defense and Anti-Drone Network, or ADN. If the first two layers fail, this is the last chance for survival right at the terminal phase.
Correct. Layer 3 is the inner skin of the defense. It's focused on terminal interception and low-altitude threats, especially the massive influx of drones and loitering munitions that might have slipped past the outer two layers. It is the immediate close-range protection.
The blueprint describes the goal here as creating a continuous dome. What does that mean in practical terms, given how vast the region is?
It means creating a 247 high-density protective coverage dome that is, in theory, impenetrable, specifically over the most critical and sensitive areas. It can't be static. It has to be constantly monitored and maintained, like an umbrella that never closes.
And what are the protected assets that this dome specifically covers? We're talking about targets of immense cultural and economic value here.
The list is extensive, and it reflects the alliance's priorities. Holy sites like Mecca and Medina are the top priority, requiring zero tolerance for failure. Also covered are national capitals, key military bases, major airports, critical nuclear sites, and high-value energy infrastructure.
Things like oil processing facilities, pipelines, shipping choke points.
Exactly, like the Suez Canal and key Gulf ports. Protecting these assets stabilizes global energy flows, which the blueprint recognizes as essential for internal security and external influence.
To protect these assets at close range, the blueprint uses a mix of kinetic and non-kinetic systems. What are the specific close-range assets in the kinetic category?
The kinetic assets are high-volume, quick-reaction, short-range air defense systems, or ESH-ORAD. These include systems like the Turkish Korkut, Pakistani LY-80, and various Saudi Asharad systems. They're designed for rapid engagement of rockets, mortars, and close-in missiles.
But because of the drone problem, Layer 3 seems to rely heavily on non-kinetic countermeasures. This is where the budget savings and tactical advantage really shine.
Absolutely. Drones are best handled by overwhelming them electronically. It's far more cost-effective than using multi-million-dollar missiles. The system integrates powerful Turkish and Pakistani advanced jamming equipment designed to disrupt GPS and control links. It also includes specialized UAE anti-drone interceptors, basically UAVs designed to hunt and destroy other drones mid-flight.
And what about directed energy? The mention of lasers sounds like science fiction becoming reality.
The blueprint notes the optional future inclusion of Iranian anti-drone lasers. This highlights the drive toward using directed energy weapons for cheap, rapid, and high-volume counter-drone capability. Lasers offer virtually instantaneous engagement at a very low cost per kill, which solves the economic problem posed by large, cheap swarms.
Okay, that structural overview shows us the what, but Section 3 moves into the who and the how: command, control, and mobile assets. This must be the most challenging part, creating a single military authority that crosses so many borders.
This is the organizational linchpin, the MADC, the Muslim Air Defense Command. You cannot achieve a unified shield across 3 continents and 2 billion people without a central authority capable of managing instantaneous life-or-death decisions in milliseconds, divorced from national political inertia.
So let's talk about that authority structure. Where is it located, and how is the hierarchy set up to ensure redundancy and trust?
The blueprint establishes the primary command in Pakistan, leveraging its existing strategic depth and technical expertise. But crucially, the secondary command is established in Turkey.
So it's not all in one place.
No, and that geographical split is essential. It provides strategic balance, critical reach into the Mediterranean, and it ensures total system redundancy. If one command center were compromised, the other could assume full operational control instantly.
The MADC has some incredibly complex key management functions. Let's start with fusing all that data from Layer 1.
The MADC's core, moment-to-moment task is managing the radar fusion centers. This is where all the raw, messy data from Layer 1, from Turkish space assets, Saudi ballistic trackers, Egyptian radars, is instantly processed, deconflicted, and fused into a single high-fidelity tracking picture. This common operational picture is the foundation for everything else.
And then the most politically charged step: interceptor allocation.
This is the nerve center of Layer 2 and the MADC's biggest test of trust. The MADC decides which nation's assets fire in a shared threat scenario. This requires that instantaneous, AI-assisted calculus of which system has the highest probability of kill, the shortest flight time, and the most cost-effective solution, regardless of its country of origin.
That sounds great on paper, but given the historical rivalries among these states, Saudi Arabia and Turkey, for instance, is it really realistic that they would grant MADC unified launch authority over their most sensitive hardware?
That is the critical strategic question that the source implies must be overcome. The blueprint assumes that the shared existential threat, the fact that isolation leads to certain failure, is a powerful enough motivator to enforce these protocols. The MADC acts as a guarantor of impartial, optimal defense decisions.
So collective security over individual pride.
Without that shared launch authority protocol, the entire system is just a collection of expensive, non-cooperating batteries.
They also manage air defense identification zones, or ADIZ, across this massive area.
And ADIZ definitions are essential for managing peaceful air traffic versus potential threats, especially in shared border regions like the Gulf. MADC defines and controls these zones collectively, allowing member states to immediately identify and challenge unauthorized aircraft based on unified protocols.
It prevents friendly fire or accidental escalation.
Exactly.
What about mobile surveillance? How does MADC ensure coverage isn't just static?
They oversee the airborne early warning, or AWACS rotations. Since AWACS aircraft are crucial for persistent low-altitude tracking, the MADC dictates their flight paths and maintenance schedules. By pooling aircraft from Pakistan, Saudi Arabia, Turkey, Qatar, and the UAE, they can ensure continuous 247 coverage across the entire zone.
And threat prioritization and rapid resource deployment, that sounds like the ultimate stress test.
It is. In a complex saturation attack, say, simultaneous drone swarms, cruise missiles, and ballistic threats, the MADC has to prioritize. Which threat gets the most expensive interceptor? Which area needs mobile jamming units right now? They manage the deployment of everything based on maximizing civilian protection.
And all of this culminates in establishing those Unified Launch Authority protocols, which is the massive political leap this whole thing is predicated upon.
It defines who, under what exact pre-agreed circumstances, has the authority to issue a command to fire. The result, as the blueprint stresses, is historically significant, achieving a single airspace shield for the entire region. A threat seen in Istanbul is instantly addressed by assets in Riyadh or Karachi.
Moving to the physical assets mobilized under this command, we have the Joint AWACS and Anti-Drone Wall. The unified fleet sounds critical for bridging those geographical gaps.
It provides the vital 360-degree. This requires a highly distributed and integrated response tailored specifically for those slow, high-volume threats. The geographic scope is immense, stretching across Pakistan, potentially Iran, Turkey, Saudi Arabia, Egypt, and into North Africa. It's designed as a continuous, low-altitude defensive perimeter.
And what technologies are deployed along this massive wall? It sounds like they're prioritizing electronic superiority.
Absolutely. It's a mix of electronic and kinetic solutions. Primary among these is high-power electromagnetic jamming, using specialized Turkish and Pakistani units to disrupt GPS and control links. The network also incorporates laser interceptors for cheap, rapid defense.
And alongside those, AI-driven anti-swarm systems are mentioned. This suggests the defense response is almost entirely automated.
It has to be. A human operator cannot respond fast enough to coordinate the defense against a massive swarm. AI-driven systems analyze the swarm's behavior, predict its intentions, prioritize threats, and coordinate the necessary response in real time.
You also have radio frequency disruption and specialized drone hunting UAVs.
Right. RF disruption targets the drone's command links, aiming to seize control or force a crash. And the drone hunting UAVs are smaller, faster interceptors, often equipped with nets or kinetic effectors, acting as the last line of defense.
This all sounds like a system designed entirely around anticipating and preempting future conflicts. So now let's bring it all together. Section 4. The shield and action crisis scenarios. Let's illustrate how all these layers and the MADC actually play out in a crisis.
These scenarios really prove the value of integration. In a real crisis, the decision-making window is minimal. Seconds are often the difference between success and devastation.
Okay, let's run scenario 1. Attack on holy sites, specifically Mecca or Medina. This is perhaps the highest stakes scenario imaginable.
Absolutely. The speed and certainty of the response has to be paramount. The chain of command would begin with early warning detection, triggered instantly by Layer 1 assets, likely Pakistani long-range radar or Saudi space assets spotting the launch signature. That detection instantly triggers the highest priority alert within the MADC.
So how does the interception sequence unfold using all that diverse hardware?
The MADC instantly calculates the interception sequence. Saudi Patriot and Thiad systems would take the immediate lead due to proximity. But crucially, the unified doctrine ensures that Turkish S-400 batteries, potentially deployed nearby, provide automatic backup coverage. They'd be ready to fire if the primary intercept fails without waiting for a secondary command.
What about low-altitude threats trying to slip through?
Well, a Pakistani AWACS would be tracking the threat constantly, relaying precise targeting updates. If the attack includes a drone or cruise missile component, the UAE anti-drone network, using its jammers and interceptors from Layer 3, would immediately activate to block any low-altitude threats. The whole incident is managed by the MADC to prevent duplication and ensure 100% certainty of a kill.
Okay, next scenario 2. A ballistic missile launched at a capital, specifically Islamabad. This tests the extreme limits of long-range integration.
Here, the key is detection depth and cross-continental data transfer speed. The radar detection could originate from Turkish space assets in Layer 1, thousands of kilometers away. The MADC coordination is immediate. That threat data is relayed via the unified command, bypassing any bilateral delays.
So who fires, and how is the long-range backup provided?
Pakistan activates its own multi-layer interceptors, the HQ-9P from Layer 2 as the primary defense. But because the threat trajectory is being tracked globally by the MADC, Saudi HAD systems, which are designed for high-altitude, long-range defense, would offer a secondary cross-continental intercept option.
So if Pakistan systems fail, the Saudi systems have already been calculating the intercept, ready to fire as the ultimate safety net.
That's the principle of defense in depth.
Scenario 3 focuses on the new battlefield, a drone swarm targeting critical infrastructure, like Egypt's Suez Canal.
This immediately shifts the focus to non-kinetic defense and Layer 3. As the swarm approaches, Turkish jamming units, which might be mobile assets rapidly deployed to the region, are activated immediately to disrupt the drone navigation and control links. That's the first line of defense. Blind the swarm.
And the coordinated Layer 3 kinetic response.
UAE anti-drone interceptors would engage the bulk of the threats kinetically. And simultaneously, this is a key collaborative element. Pakistani cyber defense units would assist the MADC in disrupting the command and control links of the enemy drones from the source. It's a true multi-domain defense.
Our final operational example, Scenario 4. Oil infrastructure attack in the Gulf. This validates the core economic necessity of the system.
Energy security is a core driver for this alliance. Early detection is crucial, initiated by Pakistani space assets or Turkish surveillance. The combined response then involves the immediate and simultaneous activation of Saudi and UAE interceptors from Layer 2, covering the high-value oil facilities with maximum defensive redundancy.
And the command structure ensures efficiency, not chaos.
Absolutely. Turkey would coordinate the air command efforts via the MADC, managing interceptor allocation to ensure maximum coverage with minimum waste. The result, as the blueprint validates, is that the energy supply remains unaffected, safeguarding global energy flows.
That detailed walkthrough paints a clear, compelling picture of the strategic intent behind the shield of the Ummah. We've seen how the layers link up, how the MADC functions, and how these disparate systems are forced to cooperate.
It demonstrates the immense leap from simple bilateral security agreements to genuine, unified military integration on a civilizational scale. The goal is to move from national defense to collective defense certainty.
Which brings us to our outro. To synthesize what we've learned today, the core takeaway is monumental. This blueprint, if executed, achieves the first Islamic civilization-wide air and missile defense shield in history.
This is a paradigm shift in geopolitical power. Before this, defense relied either on isolated national capability, which we've shown is insufficient, or on dependence on security guarantees from major global powers. This blueprint charts a path to complete independence in fundamental defense matters.
And for you, the listener, summarizing the real-world implications shows why this matters beyond just the hardware.
The benefits are systemic and profound. The Ummah skies are secured, holy sites protected by multi-layer protocols, capital safe, energy infrastructure secured against saturation attacks, and crucially, sovereignty is restored and guaranteed collectively.
The source makes a powerful claim about the final outcome that really transcends military jargon. It concludes with that powerful, almost poetic image. For the first time in history, the entire Muslim world breathes under one protective sky.
It's the ultimate expression of collective security applied to the most volatile strategic domain, the airspace. It's about guaranteeing shared peace through shared vigilance and technology.
So, as we close this deep dive, we always leave you with a provocative thought to consider. This entire blueprint is predicated on achieving independent, collective security.
Which raises an important question for you to consider. What are the long-term geopolitical and diplomatic ramifications when a civilization-wide defense shield removes the necessity of reliance on external military powers for national security?
Right. If the world's major external military guarantees, be they American, Russian, or Chinese, are no longer necessary for key Muslim states to ensure their survival and economic stability, how does that fundamentally reshape global power dynamics?
How does it change diplomatic alignments and the regional balance of influence for decades to come? Does self-sufficiency lead to greater stability, or does it simply create new internal rivalries?
A question that redefines the geopolitical map entirely by shifting power away from external guarantors. Thank you for joining us on this deep dive into the Shield of the Ummah. We'll see you next time.